Hello. Today I'm going to show you how you can create your own Discord bot. Now you might be asking yourself, what would I need a Discord bot for? Well, you can do a lot of different things with a Discord bot, and you might even find a use for one even if you don't use Discord. This tutorial specifically is going to show you how you can make one that can play music from YouTube and talk to you using text-to-speech. We're going to use a combination of Discord, Docker, Node.js, and of course a Raspberry Pi. If you're interested in tinkering with Raspberry Pis, creating and configuring your own Discord bot, working with Linux, using Docker for virtualization, or making applications with Node.js, or even if you don't know what any of that is, this is a tutorial that anybody can follow, and it's a great beginner product to teach you the basics of all of these technologies. Today we're essentially making a smart speaker. Now I know that may not sound too cool initially, but hear me out because it's actually pretty cool. This is a speaker hooked up to a Raspberry Pi that you can control using Discord. I created this for a specific purpose, which I'll get into shortly, but just the concept of this alone is pretty intriguing. Why is it intriguing, you ask? Well, you can extend this concept to basically anything. Say you want Discord to control your plant watering system or something. You can issue a command to water your plants, or you can turn your lights on with Discord. Something like that. There's all sorts of things you can do with a Discord bot, and this tutorial is going to show you the process of doing so, and hopefully give you some ideas for your own bot. This project also covers the basics of Docker, which is a really cool virtualization technology that is pretty hard to wrap your head around if you're not actually getting in and trying it out for yourself. So if Docker interests you, then stick around for that too. I'm going to break this video into sections to make it easier for you to skip around to what you need to see. I also encourage you to visit my blog to check out the text tutorial, which I will be referencing for several documents and articles. Also, with my videos, I want to be as interactive as possible with my audience. If at any point any of this is unclear to you, please reach out to me so I can clarify some of the confusing parts. Otherwise, feel free to leave comments for improvements to any aspect of the video. I hope you enjoy the rest of the video. I had an idea one day. This all started at my friend's house. I was on the toilet and he starts playing this Michael Jackson grunting compilation on his shower speaker while I'm doing my business. The experience was hilarious but also agonizing, and I swore to get back to him one day. I got to brainstorming, and I came up with 3 requirements for this project. I wanted to be able to send audio through a speaker remotely at all times. I also wanted to create a deployable app that wouldn't take too much time to set up, and I also didn't want to spend too much money. Spoiler alert, I only somewhat fulfilled these requirements, but I ended up with something interesting that might actually have some practical usage. With that in mind, let's jump into the rest of the video. Let me start by showing you the final product so that you know what you're getting into. So what I have here is the final product from this project. Let me just demonstrate it for you. So I programmed 3 main features for this bot so far. The first feature being a simple text-to-speech feature. So you type in the TTS command and then some words. It'll take a minute, but yeah, you can do multiple words, so like, and it does it in this weird robotic tone, robotic voice. And it does it in this weird robotic voice. It's kind of cool actually. The next feature is a play command, so you can do play, and then I'll just grab this one. And it'll give me some feedback. And so the song is playing in the background now. I have another camera pointed at the whole Raspberry Pi setup, but it's not like you can see the sound, so you'll just have to take my word for it. It is in fact playing out of the speaker connected to the Raspberry Pi, so pretty cool. And you can see it says queuing song, so if I were to issue another play command, it would queue that song or video next. So you can play any YouTube video with this function. Of course, it's only going to play the audio, so this is good for songs or short sound bites. that song is done playing, so I'm going to show you the third function, which is save command. So you can do save and then it will save the song. And so this basically just downloads the YouTube video as an MP3 file. So that means you can save songs that are only available on YouTube, which is pretty cool. This is also super good if you're doing video editing, because you can use songs and include them in the video. And that's how I downloaded the royalty-free music that you hear throughout the rest of this video. There's certainly more that can be added on, and I do want to add more features to it, but this will get the job done for now. Now I'm going to show you how it works. I'm going to be using this beautiful diagram to explain how it all works. Here's how you get audio to a speaker from text in a Discord channel. I use the Discord.js module on a Node.js Docker container running on a Raspberry Pi. The Node application will recognize commands that I've programmed, with the main function of the application being that it can generate audio files based on YouTube videos and send them from the Docker container to its host, which is the Raspberry Pi. The Pi then interprets those audio files and plays audio accordingly when it receives them. There may be a better way to do this, but this is the way that I've figured it out. It's pretty simple, and it seems to work pretty dang good. The initial spark for this idea was explained at the beginning of this video, but there are definitely more situations where you can use this outside of just pranking your friends. You could also use it like an online jukebox. Say you had some friends over. This bot could make it so that each person individually could play and cue different songs, which means you don't have to use the same phone to cue songs. If you wanted, you could do some extra work and extend this functionality to queue up videos to watch on your TV, so it'd be like a little watch together party. All in all, it's a simple bot that can definitely be expanded to do more stuff, but that's outside of the scope of this video. All I want to do is to show you how to use Discord as a command interface for your Raspberry Pi, as well as expose you to a beginner Docker project. So now let's start getting into the tutorial. I have the instructions written out like in my last video, and I posted it on my website. I highly recommend you use this if you intend on following along with this video, as it provides much more detail for each step. You should also take a peek at it to make sure that you know what you're getting yourself into. My intent with this video is that you can completely replicate what I've made by only using the text tutorial. If you happen to find any issues with the text tutorial, or if you have any other issues, please feel free to reach out to me. Here's the list of requirements for this project. You're going to need a computer to connect to the Pi and configure the app, a chargeable speaker with a 3.5mm jack input. I have a link to the speaker that I use, but it's not the best speaker for this project because it turns off automatically if it isn't playing anything. If you can, I recommend using a speaker that doesn't have an automatic shutoff. Also, you don't necessarily need a chargeable speaker. That's just if you want to be more portable. You're also going to need a 3.5mm headphone cable. Any length will do, but you should get a longer cable if you don't want the Raspberry Pi to be in the same room as the speaker. For instance, you want the speaker in a different room or on the other side of the room. You're also going to need a Raspberry Pi 3, or you can use a Raspberry Pi 4, which is a little bit overpowered for this project. And you're going to want to set that up with Raspbian Buster and SSH enabled. With that, you'll obviously need a micro USB power cable for the Pi and a micro SD card. I also recommend using a case. You can run this project alongside other applications as it doesn't take many resources to run, so you won't necessarily have to buy a new Pi for this project if you already have one. I run this application alongside the magic dashboard that I made in my first video. I would also recommend that you have familiarity with Docker and Node.js as well as Bash and JavaScript. This will help you a lot because you'll know what's happening. But this tutorial is made so that even if you know nothing about these technologies, you'll be able to follow along. With that out of the way, let's get into the tutorial. The first thing you're going to want to do is install Docker on your computer. For Mac and Windows, install this application called Docker Desktop. If you're using Windows, I also recommend you use WSL, which stands for Windows Subsystem for Linux. This is going to allow you to run Docker commands from the command line in a Unix shell. If you're using WSL, make sure to also install the WSL features for Docker. After you've installed Docker Desktop, you're going to make a Docker user and sign into the app. You're also going to need to install Docker on your Raspberry Pi. To do this, you're going to use the startup script that Docker provides, which is linked in my text tutorial. The next thing you're going to want to do is create the Discord bot user in Discord. I'm not going to go over this myself in this tutorial because there's a great video by Drew Conley that describes the process perfectly. This Discord bot user is necessary in order for you to interact with message inputs from Discord servers, and you're going to need to invite it to any server that you want the bot to be on. There's also a text tutorial online and there's tons of great examples in it. Be careful with any examples that have the secret token within the application file, because if you're going to use the Docker Hub to deploy your project like I am, then you could risk your bot being compromised. Don't worry though, because I'll show you how to keep it safe in the next step. Now we're actually going to build the app. I stole heavily from these two articles, where the first article talks about the Discord.js library in Node.js, and the second article talks about Dockerizing Node.js apps. The first article describes how to use the Discord.js library and has a bunch of different examples. I find that I learn the best from seeing tangible examples that I can test on my own and modify to create something new, so this article is a great place to start. Keep in mind that since Discord.js recently made a relatively big overhaul, you may come across articles with outdated information, and this is one of them. However, this article will still help you get started, and hopefully the rest of this tutorial, as well as the official Discord.js documentation, will help you through the rest of the way. The basic function of any program is to receive input, which in this case would be a Discord message, and perform some action based on that input. For example, like turning that text into speech or playing a YouTube video. We'll take that concept and expand on it, storing functions into our main application file, which we'll store in a file called app.js. With Node apps, you're also going to need to make a package.json file to specify the modules and dependencies that you're using and their versions. We'll come back to this after we talk about the second article, which describes how to Dockerize the Node app, which has two main benefits. One being that you can separate it from the main Raspberry Pi OS, and two, you can have an easily deployable application that you can make updates to with just a few commands. To Dockerize the app, we create a Docker file, which holds configurations that Docker reads to create the image which you build the container from on your Raspberry Pi. I pulled most of this Docker file from the article about Dockerizing Node.js apps, but you'll notice there are some differences with mine. Depending on the version of Node that you're using and the type of hardware you're running it on, you may need to change the base Docker image here. Since I want to run this on a Raspberry Pi 3, I have the version set in my file to use an ARM32 version of Node. And I'm using version 16.13.0 of Node because that is the version of Node that the core modules for this app, being Discord.js and YTDL Core, are compatible with at the time of this recording. Before we get into the other parts that I changed in the Docker file, I think it's about time that I have the talk with you. Unfortunately, we live in a world where software isn't perfect. Security vulnerabilities are inevitable, especially with Node apps, but you should always do your best to prevent against them. Luckily, Docker has some pretty neat built-in security features just based upon how it works, which you can read more about here. But even so, Docker still isn't perfect. This is where you can leverage Vulnerability Scanner with the command docker scan to check for vulnerabilities in your Docker images. As you can see here, most of the vulnerabilities in this project are due to the base Node image being used. Just look at the difference in the number of vulnerabilities by specifying a more specific version of Node here. There's a nice cheat sheet provided by Snyk, the third-party scanner software that Docker's docker scan command uses, which includes a bunch of different things you can do to help keep your Docker apps safe. I also reference a few other articles when building out my Docker file. I'll probably be doing a video in the future going more in depth on how to secure all the apps that we build on this channel, but for now, you'll need to understand that there is always a security risk whenever you connect anything to the internet. Let's get back to building the app. The last thing we need to do is to create the package lock JSON file. For the sake of best practice and added security, you're going to want to get in the habit of doing this for Node apps, even though it's not technically necessary. This file narrows down what dependencies that node needs for your core modules specified in the package.json file, and only installs what is necessary. Therefore, limiting any added bloat in your project as well as unnecessary and potentially vulnerable dependencies that would otherwise be installed if you didn't have this file. To generate this file, we need to run npm install. But how can we do that if Node is not installed on our host machine? We could install Node and npm on the host machine, but we could also use another cool trick that Docker can do and spin up a Node container on the fly and use it to generate a package lock JSON file. I found this trick on Stack Overflow, and it's pretty simple to use. You just run this command and substitute the directory for your directory, which contains your app.js and package.json files. Within the container, you can run npm install and it will generate the package lock JSON file along with the node modules folder. Exit out of the container and we're good to go. Actually, we need to use this trick again because we also need to contact the Discord API to register the Discord bot for the ability to use / commands, which seems to be a new feature in Discord.js version 13. The official guide is very well documented and easy to follow along, but here's the step-by-step process visualized. You need to create two files called deploy-commands.js and config.json in the directory. You can copy-paste the file content from the guide and just replace the parts that need to be replaced, which are the command names in the deploy commands file and the client ID and the token, which you can find in the Discord developer portal. You also need to find the guild ID, which is your Discord server ID that you'll find on Discord. To find this, you need to go to User Settings, then go to the Advanced Settings section, and then enable Developer Mode. Then you can right-click your Discord server and select Copy ID. After you change all those things, run the ad hoc container using the same trick we used to generate the package lock JSON file. Finally, in the container, execute the node some npm modules just necessary to get to the Discord API. You have to go through this whole process every time you want to add or edit commands in your bot. With everything in place, you can build the image and push it to the Docker Hub using these commands, so you can pull it down to your Raspberry Pi. If you wanted to not push your image to the Docker Hub, there are ways to generate an image locally, but that would defeat the purpose of an easily deployable Docker app for this project. Now, we can finally run the app. Let's pull it down onto our Raspberry Pi, and then run it using this command. Quick note. The app requires you to input the Discord bot client ID, which is the token I was mentioning earlier that you need to keep secret and secure. You wouldn't want to store this in your application files because then whoever pulls your Docker app would be connecting to your Discord server. The best way that I found to give the client ID to the app is to use environment variables. You're going to want to store the environment variable in a file and supply it to the docker run command like this. After that, make sure the Docker container is up and running using the docker ps command. You can also check the console output of the app using the docker logs command. You'll need to use the container ID from the docker ps command to run the docker logs command. These commands are going to be your best friend when troubleshooting. I made a script to help me restart the bot that I've included in my GitHub repository along with some of the other startup scripts that I use. So, I wasn't actually sure how to process everything from within the app container, which may be possible, but I don't know Node or Docker well enough to do so. Instead, I created a script to process the audio files on the Raspberry Pi host rather than within the Docker container. It's not the prettiest script I've ever made, but it will move, play, and queue MP3 audio files received from the bot application. So, by that measure, I think I'm succeeding. I tried using Python to write the script, and I couldn't get it to work, so my sysadmin side took over and got it done with Bash. If somebody can figure it out with Python, that would be preferable, so let me know if you have any ideas in the comments. Anyways, since this is part of the process that actually plays the audio files, whereas everything in the Docker container is what generates the audio files, this script needs to be running while the Docker container is running. If you want to copy my script, be sure to create the folder structure referenced in these variables and in other places in the script, or change the script to point to different paths. Notice that I'm not able to get back to my command prompt while I'm running this script. This means we'll have to set up an automatic job that will run the script in the background. But let's test the bot first. With everything in place, we can finally test the bot out. First, I'll try the text-to-speech function. We can see here that the command is processed and the text is transcribed to a file, which is then read by the script referenced in the previous step, running to transform that into audio. I stopped that script from running, then ran the play command to check out the file being generated. We can transfer this file to my computer and play it to see that it's generating. Yeah, it's safe to say the YouTube audio downloader is working. Be sure to test out the other functions, but I'll leave it at that for now. Now that we know the bot is functioning, we can create scripts to help us keep it up and running. We need a way to start the bot automatically. For this, we're going to use cron jobs. Quick disclaimer, there are other ways to do this, but this way made the most sense for this project. Depending on how long you want to keep the bot active, you'll need to figure out a schedule and configuring cron jobs accordingly to execute them automatically so that the bot is available when you want it to be. I keep mine active throughout the day and turn it off at night, and this is how you configure that. The cron tab is a place where you can configure cron jobs, which are automated jobs which run scripts at specified times. Notice the notation with the asterisks and numbers. This tells your system when to run the scripts. You can mess around with different configurations to get super specific about when you want to run something. I highly recommend you check out this site for help with the syntax. Notice that I pull the image we made and then create and run the container. This means I'm always going to have the latest version of my app. You should change this based on your preference for if you want the latest update of your image or if you want to pull the image manually to control which version of the image you want to run. I added a nightly reboot at 12 AM and don't start my apps until 8:30 AM because I don't need them to run overnight. You can change this to fit your own needs. Some commands require root permissions, like rebooting, which is why the reboot command is in the root user's cron tab. Now we have everything in place. Our Node app lives within a Docker container, which then runs on the Raspberry Pi, which we use scripts to manage. These are optional, but if you're planning on making edits to the bot, you're probably going to want to build these scripts to make your life easier when you're building the app. For building the app, wherever you're building, likely not on the Raspberry Pi itself, you're going to use this script. Ignore the git pull part if you're not going to be using GitHub to push your code. For restarting the app on the Raspberry Pi, you're going to use this script. And if you're deploying this bot in multiple locations, you're going to want to run this script in order to install dependencies for this project. In conclusion, the bot we made in this video is pretty much just for fun and doesn't really have much practical usage on its own. When I get some time, I do want to expand on it and make it more useful, but I'm happy with what I have for now. Let me know if you have any more ideas for more functions of this bot, and I'll be sure to reply with my thoughts. Hopefully you got something out of this video regardless of all the shenanigans, and I'm sorry for taking so long and making another video for this channel. Leave a like if you liked this video, and thank you so much for watching.